This experiment is about heat generation during drilling. When you drill through a bone, you produce friction, and this friction produces and generates heat. The longer you have this heat and the higher the temperature is, the more damage you do to the bone. So you'll get bone necrosis. This is something we have to avoid, and we can avoid this by using very sharp drill bits. Let's look at the drill bits that we have. These are 4.5 millimeter drill bits. One is sharp and one is blunt. Now I would like to explain to you how you can differentiate between a blunt drill bit and a sharp one. If you look at the points of the drill bit, look exactly at the point, then you can see that the blunt one reflects light and the sharp one does not. We will now use the sharp drill to drill through the bone, and we will see how much heat is generated while you go through the bone. Would you like to start? We will apply this drill sleeve here so that we know that the drill will go exactly into the bone without moving and without vibrating. Now again, this is the way you place the drill bit into the drill. You push this little knob up, you let go, and then you see if it is stable. And you work it to see if it's going in the right direction. Yes. Then you apply it just by putting it into the drill sleeve. Okay, at your leisure, go ahead and drill through both cortices. Okay, let's look at the monitor. What has happened? Now, the temperature that was here before is starting to recede again, and the maximum temperature that you produced is 55 degrees. 55 degrees for a short time may not produce too much soft tissue necrosis. But if this takes more time, maybe 20, 30, or 40 seconds, you're producing soft tissue necrosis. Now let's try the same thing with a blunt drill bit. Now the temperature is 7 degrees higher than before. This may not sound like very much, but because the influence of the heat is not linear, 62 degrees can damage the bone in seconds. So for the third part of our experiment, we're going not to use a drill bit, but we're going to use a Kirschner wire, which has a trocar tip. And I'd like for you to take this and put it into the drill. Okay, now apply it to the bone. Go ahead and push. Okay, you may take it out. So what is our max this time? 82 degrees. This is caused by the trocar tip. So essentially, you're burning your way through the bone and not drilling your way through the bone. So now let us discuss the results of this exercise and what you can learn.
In the online faculty support packages, you can find faculty guides for each station and, where appropriate, topics for discussion and frequently asked questions. In case of questions, please send an email to templates@aotrauma.org.